called Solving Problems Involving the Max and Min of Quadratic Functions. I must tell you that many students believe this is the hardest stuff in all of 11. But you have me, so it's going to be all right, because I'm not going to teach this the regular way. I'm going to teach this the way it'll help you to understand what's going on. That's the biggest problem. Actually, the math here won't be too bad. The math, if we can get to the math. Making the equations will be extremely challenging. Solving problems involving the max min. Find the minimum product of two numbers whose difference is 12. It's questions like this that I think people make fun of when they get older. Shh. Because they're so complicated looking. Well, they're so simple looking, except so complicated. So what I want you to do, I photocopied your handout single-sided on purpose. It wasn't a mistake. I want you to flip your sheet, flip the front sheet over, and we're going to solve this problem without using any 11U math whatsoever. In fact, the grade 6 version of you would probably understand what I'm going to do here. Then when I'm done, we'll talk about the weaknesses of this strategy I'm going to show you. Okay? So I'm going to go over to a blank page. Oops, I want to fit this to width first. Lots of lead up. Can you tell I'm not concerned. I'm focused today. Even with the Santa costume and the whole thing, I'm like, oh, all morning I was thinking about exactly what to say here. I got to fit that to width too. I got to go get that question. Where is it? It's over here. Grab that question. Copy, over here, paste. You're on the back page, yes? You flipped it over. And we're going to try and solve this problem in a way that's perfectly understandable. And if you see the weaknesses of this method while we're going, I like it, okay? There's two numbers out there. And we want to find the minimum product. Well, first of all, what does product mean? Multiplying. Okay, so let's just put that on there. You can flip your sheet back over for a second and write multiply beside there to go, okay, we know these two numbers have to be multiplied together. That's what's got to happen. Please don't underestimate what I'm about to do when you do see the weaknesses. This is a powerful method to handle this question. I'm going to make a column called the first number. Complicated title for my first column, the first number. Yes? Don't let the size of my table intimidate you. There's not going to be much going on this table, but I'm just making it big so you can see what's going to happen. Then, here, the second number should be sort of okay so far. And then I'm going to make a column called the product. And I hope I left enough space. All right. I'm going to start with 0. There's no reason to start with 0 except like, well, what number am I going to start with? This method doesn't care what number you start with, but I'm going to start with 0. Now I need somebody just a little bit clever to tell me if the first number was 0 and the difference between the numbers is 12, what's the second number? 12. Is that hard? No, pretty good so far. The difference is 12. I do want to talk about how he got it. Maybe it was too easy to think about. But we got to get to that if we're going to ever get the powerful method going here. So the product then would be 0 times 12, which should be 0. I'm off to a great start. I'm trying to find the minimum product. I want the lowest number I can get in this column. And you say 0 is the lowest number. 0 is not the lowest number. There's lower numbers than 0. And we'll get to that in a second. So instead of the first number being 0, I'm going to make the first number 1. If the difference between the numbers is 12, and the first number is 1, what's the second number? 13. I did the long pause there. Hopefully that meant everybody was like, yeah, I know what it is. I just don't want to share it out. See, the difference is 12 between these. So the product is 1 times 13. Now something's gone wrong already with my method. If I'm trying to get the lowest number, what I'm doing is making the product go up. We agree? 13 is bigger than 0. I'll keep going just to get the method clear in your mind. Because remember, our goal is not to do it this way. Our goal is to understand this method to do something better. Okay? First number, what if it's 2? What would the second number be? How did you get 14? Yeah, it's a pattern. But if you really wanted to get from 2 to a number whose difference was 12, add 12. Okay, that's key to understanding the big method, is to go, how do I get the second number? So I'm going to start writing it that way. This is 2 plus 12, which is 14. You can be unfazed by that, but that's a key move in all this, actually. So my two numbers are 2 and 14, and hopefully that's enough to go, I'm going the wrong way. I'm not getting smaller products, I'm getting bigger products, and they wanted me to minimize the product. That was the wrong way to go. And so you don't have to draw a line here. I'm going to draw a line so you realize I'm changing my thinking now and going the other way. I shouldn't have gone from 0 to 1. That started making bigger products, which you might do in a different question. Maybe a question says maximize the product, and you might want to keep going this direction. That clearly was the wrong thing. So now I'm going to go the other way. -1. Maybe that's a better number. Maybe that'll give me a lower product. If the first number is -1, what's the second number? How did you get 11? I just added 12. Okay, it seems like nothing right now, but it's key to understanding. Why people have trouble with this type of question is understanding where that's coming from. -1 plus 12, which is 11. And if I find the product, -1 times 11, I get -11. That's the lowest product yet. I am winning this question. I've now found a lower product than 0. Maybe you're surprised this thing went negative on us. Maybe. Next lower number, -2. To get the other number, I'm going to add 12. To get 10, and its product is -2 times 10, which is -20. Some of you are already showing one weakness of this method. When I first started this, everybody was paying attention. And I'm not criticizing you. I'm not being a teacher. I'm really not. I'm not criticizing you for your attention span going away. Just remember that I can tell out there that some people are like, I'm getting bored now. All right, it's okay. It's okay today. It's okay. Now I'm down to -20. Was that better? That was a lower number. So I keep going. -3. Add 12 to get a number so that their difference is 12. This time I get 9. -3 times 9, -27. Now, if you are getting bored and looking at this, and this is going to go on forever. It's not. I can tell by what's happened here. It went down by 9, then it only went down by 7. I'm on my way to something here. Something's going to happen here along the way. Let's see, -4. -4 plus 12. So I got to do -4. Over here I got to do -4 times -4 plus 12, which is -32. Mr. Todd, why did you write it that way? That was stupid. I'm like, I'm up to something. I'm up to something, okay? All I did there was I didn't figure out what -4 plus 12 was before I multiplied it. Not really a big deal. It may have just looked lazy, is maybe what happened. Is it still going downwards, though? Still going downwards. -5. The other number would be -5 plus 12. Then I got to go -5 times whatever -5 plus 12 is. Maybe I can't even do -5 plus 12 in my head. So I let my calculator handle it. I get -35. Still going down. Not going down by as much, though. Slowing down. -6. -6 plus 12. So that's -6 times whatever -6 plus 12 is. Don't read too much into what I'm doing there with the -6 plus 12. You can imagine I just got lazy there, and I got -36. That's the new lowest product. -7. The other number will be -7 plus 12. and I get negative 35. And I'll put 3 exclamation marks after that because the method has worked. I have found the lowest product. The lowest I got was negative 36. Find the minimum product. I can answer the question. Minimum product. Negative 36. What are the two numbers? That's the other thing it asked me. I think that was part B. Part B asked me what the two numbers are. They were negative 6 and positive 6. I'll figure that thing out now. It seems like I'm being tricky, and I'm not. I'm trying to show something. Whew! I can think of 3, 4 weaknesses of this method. Let's see how many you can come up with. It takes forever. Easy to understand, though. Would you agree if I took this to a grade 6 class, I might have had to go slower than I went with you? But if we took an hour to do this, they'd be like, yeah, I totally get what you're doing there. Yeah? But it can take forever. What else? What other weakness does this have? Well, I'm going to do another one in a minute, and you're going to see the problem with how I went here. It might have a hole in its method by the numbers I chose there. We'll talk about that in a minute. The third one is, I stopped there and I went, oh, that's it. That's the lowest one. Because it started coming back up again. How do I know it doesn't go up for a bit and then go down again and go below negative 36? See, it's not complete. I would say that's the biggest problem I have with this method. It's not a complete method. I don't know for sure I've got the answer. It really looks like I have the answer, and in this particular case, I do. Maybe positive numbers, it does come back down again. Yeah, right. So it ended up working. But it sort of feels like, are we sure this is going to work? Right? Now you can flip your page over to the front side. And if you did that on the front side, don't panic. Just do this one on the back side. This is the 11U method. Yeah, I just cracked all my knuckles. A little bit of warm up of my shoulders here, because here we go with a different way to handle this. Here's how we want 11U students to do this question. Get ready. Find the minimum product of two numbers whose difference is 12. Let x be the first number. There. Suddenly algebra just came in off the bench and said, put me in, coach. I'll do this question. I'm going to put a blank there, because that right there is the toughest moment in the whole question, right there. All your brain power has to be right there. Be the second number. Everything about this lesson is right now. Let blank be the second number. You could put Z in there. You could put Y in there. And all of those things introduce a second variable, which it's a big lesson in math. Don't bring another variable in unless you really have to, because things are going to get difficult. We want x plus 12. That's the toughest moment in the whole lesson, and turns this question on its end and goes, oh, this isn't so bad because I used x plus 12. It'll be awfully tempting to write y there. And you could. You could write y. If you do write y, you're going to have to go over here and go, okay, how are y and x related? And the answer is x minus 12, or sorry, x plus 12 equals y. You're going to go over there and do something like that. You go, what is y? It's x plus 12. See, if you do put y in there, at some point you're going to have to make a move over to x plus 12. Now, so the product, I don't know why I wrote so the, is all one word. So the product is x bracket x plus 12. And I can't resist drawing a smiley face, because if you get to that point in the question, it'll be okay. I know why people think these questions are so dangerous. They can't start them. If you don't know how to do those 3 lines, you can't start the question, you can't do anything. And then it's scary, right? Shows up on a quiz or test and it's worth 4 or 5 marks and you can't do anything. That's a problem. Santa's pants are doing the funky chicken here. All right. Therefore, P equals x times x plus 12. Good. So what, you say? Yeah, so what? What does this have to do with yesterday's lesson? What could we do yesterday? No, Friday. Friday it was. We could take a quadratic. Is it a quadratic? It is. Oh, it is a quadratic. We could take a quadratic and put it into vertex form. And once it was in vertex form, we could find the vertex. Do we care that we found the vertex? I don't know. Let's try it, and then hopefully there's an aha moment coming up here. Product equals x squared plus 12x. The magic number? What's the magic number? To complete the square, to find the vertex, he said loudly into his microphone. $36. Now, okay, I looked out and there's some fear in some people's eyes, like, I don't know what he's talking about. So maybe this is the most important part of the lesson for you, if you had fear there. Plus 36. Where did you get the plus 36 from?
It was Carter that really told me to say that, to be honest.
Okay. Carter, why? Divide by 2 and square it.
Oh, yeah.
Yeah. I'm slowing down on purpose. I'm trying to collect in people who are like, oh, I didn't quite understand that lesson. I didn't get through all the homework because of the test. I'm trying to collect them in and go, oh, yeah. To be able to complete the square, the magic number is take half of the b value and square it. So let me just write that over here on the side. That's what most people do. Somewhere on the side of their notes is like 12 divided by 2 squared, which is 6 squared, which is 36. Usually people do it off to the side there. They think through what has to happen here. And why is it so magical? Because now these first 3 terms factor. Not just factor, they factor beautifully. What's the what number
6
multiplies to 36 but adds 12? 6 and 6. See, the 36 completed the square. So this thing now becomes equals x plus 6 squared minus 36. Which we can get the vertex from. And you're still out there going, I don't care about the vertex. This was about finding the minimum. Let me just say that again. I don't care about the vertex. I was trying to find the minimum. The vertex is the minimum. Okay? So let me just draw a tiny little graph. Oh, -6, -36, there. What's that?
It's in the bracket, so it's the opposite. It's left.
Whole chapter to go, oh, it's left 6. Yeah? Went pretty well. Went pretty well in the test. I was pretty happy with the test. Vertex.
Get it back to me.
You cannot get it back today. You can get your mark today. I have them all updated. I didn't get a chance to print them. So it depends on how long this lesson takes me. I only have 3 examples, though. Am I correct? 3 examples, and the last one's the easiest one. Yeah? Okay, well, I was lying before when I said I don't know why people have trouble with this question. People have a lot of trouble with the answer to this question. First of all, we've decided that x should be -6 to get a minimum. What is x? Does anyone recall what x represents in this question? It's the first number. Okay, these let statements, hopefully some teachers have tortured you with let statements along the way, and they acted like it was about communication, and they were wrong. It's not about communication. It's about knowing what the heck we're talking about. Let x be the first number. So, therefore, the first number is -6. There, right there. The minimum product I'm running out of space down here. Minimum product is -36. Sorry, that is too low. Just give me a second. You iPad people will love what I'm going to do next. The rest of you, you don't get this kind of technology. There we go. I got some space. The minimum product is -36 because that's what I was graphing was product. And finally, the second number. Oh, I don't know how to get what's the second number? X plus 12. That's why those let statements are so important. Take your time on the let statements. Is -6 plus 12 equals 6. Now, does this method solve the problems we identify with the other one? Is it faster? Yes. And if you disagree, the only reason you're disagreeing is because the answer was 6. If the answer had been 86, we'd still be working on the table. Yeah? Whereas if the answer is 86 here, it's the exact same speed. Second, are we sure it's the only answer? Yes, because it's a parabola and we know our base function x squared only has one minimum. So we're not worried about this getting another minimum somewhere else. The third problem I hadn't mentioned is what if it's a decimal? This handles decimals, no problem. Whereas the table in decimals is going to be like, huh. Any questions about that? Those are hard. If your brain hurts, good, we've had a good day. These will hurt your brain. Do you need more time? Shh. I'm going to get a projectile to fling at the front row for talking here. What am I going to use here?
Hey, Carter. He's the biggest target. Wow. Like, you're going to dome for that.
No.
Staple Nathan's mouth shut.
Clang. That is, actually hear the clang on the video. Wouldn't that be awesome? Mom, you gotta listen to this video. Hit him with a 3-hole punch. But do you have any questions? Shh. Shh. These are difficult. Book some time to look these over and fight with them. They're not the kind of homework that you're just going to go zippity zip, woohoo, done my homework. That's not the way it's going to go. And we're now borderline doing some real math finally for the first time in a while. Grade 10 and 11 don't have a lot of real math in them. This is now coming back. You're like, oh, maybe this is how they do stuff. Yeah? It is exactly how they do stuff. I guarantee the people at Apple do math like this all the time trying to figure out what price they should put on the iPhone. You know, what's the maximum profit here? It's all about money. Oh, a money example. Thank goodness. Here's a nice, simple money example for you. It's not about iPhones, but it's very similar to what they talk about when they go to do setting prices. Let's read this carefully, and then we'll flip our page over again on one of the blank sides to do a table, the old-fashioned way. We'll do the old-fashioned way. Then we'll do it with algebra. Student Council plans to run the annual talent show to raise money for charity. Last year, tickets sold for $11, and 400 people came to the show. The Student Council has decided to raise the ticket price for this year's talent show. They want to make more money. They're going to raise the ticket price. But they know every time they raise it $1, 20 people aren't going to come. How do they know that? Well, that's an economics question. Somehow, they have done enough research, market research, to know this is what's going to happen. What ticket price should they use to maximize revenue? Okay, I say flip your page over. If you're doing it on the front page, it doesn't matter. I want you to have both methods, so it doesn't matter, but that's why I copied them single-sided. So I'm going to go over to the other side. But this time, because I know I need a little more space, I don't know why I know that. I'm not going to copy the question over. I'm going to go back and forth, okay? My first column, number of $1 price increases. That's going to be the first column. How many times should they increase the price? Or should they not increase the price? We might find that out. We may find out, no, that was we already did the best we could do. Then this column will be number of tickets sold. And then the last column will be revenue. Have you heard the word revenue before? That just means money in. But I'm not teaching a business course, so if on the test you're like, what's revenue? I'll tell you, that's money, the amount of money they're going to bring in. So they could not increase ticket prices. I'll start at 0 this time. Don't increase ticket prices. If they don't increase ticket prices, they're going to assume that they're going to sell the same number of tickets. I forget how many it was. 400. I forgot a column. I'm going to try and fit it in here. See if it fits in here for you. I'm sorry if I messed you up. I forgot to do ticket price. I know, if I messed you up, I really apologize. I was supposed to do number of tickets. Oh, yeah, just erase the line. It's like, it's no problem. If they don't increase the price at all, what's the ticket price? 11? So last year's revenue was 400 times 11. Last year they made $4,400. Here's the big question. Not 4440, 4,400. I'll get my calculator ready. 400 times 11, 4,400. Maybe that's the best price. Maybe that makes them the most money. Somebody says, no, let's increase ticket prices. Let's increase the ticket price one time. What will the new ticket price be then if they increase it by $1? 12. Again, hopefully you're like, yeah, it's not so bad. And if hopefully this method you could handle even in grade 9. How many tickets sold though? 380. How did you get it? So this is 400 minus 20, which is 380. So if this all comes true, and we're right, this year, if we increase the ticket prices by $1, instead we'll have 380 people, $12 per ticket. Does that make us more money? $45.60, it does. It's so counterintuitive. You're like, you sold less tickets, but you made more money? Yeah, because we got an extra $1 out of all these 380 people. It more than made up for it. This is why some stadiums sit empty out there. Not empty. This is why some stadiums are not, they don't push for selling out. They know they're going to make more money if they don't sell out. Weird. Weird. Well, the rest is pretty repetitive. I'll do it a little bit faster just in case you're getting bored. What if I do 2 $1 price increases? What's the new ticket price? 13. I'm going to write it slightly different, getting ready for the algebra, all right? Setting the table for the algebra. It's now going to be 11 plus 2. Agreed? 11 plus 2, that's what's really going on here. I've done $2 ticket prices increases. And then this is going to be 400. Subtract 20, but twice 360. And if the way I'm writing these seems stupid, it's everything. It is everything to be able to handle the algebra. So over here, I'm going to start writing it like that. Ticket sales is 400 minus 20 times 2. And I'm multiplying that by 11 plus 2. What is it? 360 times 13. 4680. Making you believe maybe that I should just increase prices by 50 bucks. But it went up by 160. The next time it only went up by 120. This answer isn't too far away. Yeah, it's not going to be too many increases I got to do here. If I do 3 $1 price increases, my new ticket price will be 11 plus 3, which is 14. My number of tickets sold is 400 minus 23 times, which is 340. And I know what you're thinking because we trained you. Can't I just go down by 20s all the way along here? And the answer is yes, but it does not get you ready for the algebraic version of this. So now I'm going 400 minus 20 times 3. And I'm multiplying that by 11 plus 3. Yes, I know what those answers are. 340 times 14. 340 times 14. 4760. Looking weird on my page there. It's weird. Does anyone want to, can you remind us what the weakness of this method is again? It's forever and boring. Its main strength, though, is for most people it's easy to understand. It's easy to understand what I'm up to. 4 ticket price increases. New price 11 plus 4 is 15. That gets down to 320. So over here it's 400 minus 20 times 4 times 11 plus 4. 320 times 15. Okay, wake up for a second. If you've fallen asleep, wake up. Maybe the most important thing I'm going to say today. If you want to get from the first column with a 4 to this column, you go 11 plus the first column. Good? To get the second column, you go 400 minus 20 times whatever's in the first column. Just bounce, let that just rattle around in there for a while in preparation for the algebra in a moment. I don't know how many more times I got to go here. Let's do 5. This is 11 plus 5 is 16. This is 400 minus 20 times 5, which is 300. And I got to go 300 times 16. Oh! 400 minus 20 times 5. 11 plus 5. I get 4,800 again. Same answer. See, it was going up, going up, going up, going up. Now it's leveled off. I think it would be natural to ask what the next one was. So I'll do that one quickly to prove it. It starts going down after that. 4760 it's back down to. So should we increase the price by $4 or by $5? 5. Well, gives the same. Gives the same answer, okay? So either $4 or $5 would be the answer from there.
But you should do 5 because it's less crowded.
5 less crowded. 4, maybe we sell more popcorn.
No, it's not. Stop copying Carter, man. The original.
It's less than 5, you might get more people. Because people might see 4 as being cheaper.
Yeah, maybe. Maybe. I'm not sure. Can we agree that it's either 4 or 5?
They're going to get you the same price.
Yeah. I think if I was selling at a big stadium, I'd probably go 4 and get more people in the building buying popcorn and Pepsi and souvenirs, stuff like that, maybe. But okay, separate issue. We can leave that for economics class, okay? Or business class. Business class. Can we do it with algebra? Yeah, let's do it with algebra. Let's do the exact same thing with algebra. Let x be the number of $1 price increases. Is there other choices for x? Yes, but over the years, we've decided that this is the easiest one for people to handle. So, the new ticket price is how do I get the new ticket price? If I'm increasing it by
X plus
11 plus x or x plus 11, either one. Here's the tough one. We expect to sell tickets. Tough one. How many tickets? If we increase it by x, how many tickets do we expect to sell? Take a look at that column. I tried to set it up here. When it was 1, it was 400 minus 20. 2 is 420, 400 minus 20 times 2. 3, 400 minus 20 times 3. 4, 400 minus 20 times 4. How about x? 400 minus 20x. Don't underestimate how difficult that line of mathematics is to come to. That is difficult. Look at how long it took me. 30 minutes to get to the point where I could explain why it's 400 minus 20x. Now I can make an equation for revenue. Therefore, revenue will be equal to 11 plus x times 400 minus 20x. Now, is that thing a quadratic? Yes. Hard to see right now until I do this. All I do is FOIL that out. And then I'll just rearrange and collect. And again, I'll pause there just in case somebody wants to stare at that rearranging and collecting and see if they follow it or if they have any questions. Now, why do I care that it's a quadratic? We want the vertex. And what word in this question tells us, triggers us to find the vertex? Yeah, as soon as you see maximize, you're thinking vertex. I'm going to go through the whole process and talk about the vertex again. But to find the vertex, we need to be in vertex form. To get into vertex form, we need to complete the square to find the vertex. Here's the steps to complete the square. This one's different, right? Coefficient out front. When you did coefficient out front ones in the homework, on last night, if you did it, you might have been like, why? Why does he put coefficients out front? I'm like, whoa. I don't put coefficients out front. Life puts coefficients out front. This was just some revenue example for student council, and Life put it out there. Here's the steps. Common factor off. The negative 20. That allows me to get to the magic number. How do we find the magic number? Negative 9 divided by 2 squared, which is negative 4.5. Okay, hold on. Last night's homework is like, do it in fractions. What is it about this question that says decimals are okay? We're okay with decimals this time. It's price, it's money. We're all about decimal money. No one goes up to anyone and says, can I borrow $5 1/3? Right? We use decimals with money because it's easier, right? But negative 4.5 squared, woo. $20.25. There's the weird magic number. Brace yourself. A little bit of tough algebra coming here. Plus 20.25. Minus 20.25. Plus 4,400. And if you're out there thinking, oh, this is a problem. This chapter is a problem. If I can't complete the square, I can't do the questions that say complete the square, first of all. If I can't complete the square, I can't do the word problems that need to complete the square. So if you didn't do the homework from yesterday, that's your first task tonight. Do enough of last night's homework that you feel, okay, I can complete the square now. Because without it, you're done. Okay, next line. Factor this thing. Half two things that multiply to 20.25. Look where I'm looking. Two things that multiply to 20.25, but add to negative 9. It's right there. Get your highlighter out. You'll have it right there. 4.5. Oop. Whoops. X minus 4.5. And then, I'm not going to make this mistake. If you don't know why I did this, ask me. I get 405. Little divider line here. So I get R equals negative 20, X minus 4.5, plus 4805. I don't like how small that's getting. There. The maximum will be when X is 4 point. That's why that other table was so weird. And we were arguing, should it be 4 or 5? The math goes, neither of those. 4.5. And I'm going to make $4,805. Is that more money? It's an extra $5. You're like, oh, wow, what do I care about $5? Maybe you don't care about $5. Maybe for printing the tickets, you're not going to do 4.5. I'm not saying that that's what the student council should do. I'm saying if they want to make the most money, $4.50 is the way to go. Here's the picture to help you answer the question. Revenue, X. 4.5, 4805. Woo. They should raise the price $4.5 to $15.50, making $4,805. Is the algebra faster? Yes. And you might not think so because the answer was 4.5, but if the answer had been 87.4, we'd still be working on the table. Does the algebra guarantee we have the only answer? Yes, because we found out it was a quadratic. So those are the advantages. Does the algebraic method handle decimals? Yes. Putting all my projectiles away except one. Yeah, what he said. Do you have any questions about that? Besides, this is really hard. Mr. Shaw, are you serious? Yeah, really serious about this. There's good and bad news. Completing the square with coefficients is difficult. The good news, it's very repetitive. Like every question does the same thing. So the first one you do, you're like, oh, that took forever. Second one, you're like, oh, I hate this. Third one, you're like, oh, that went a little better. Fourth one, I'm starting to move through this a little faster. But there's a third example, isn't there? Do you need more time here? $4.50 to $15.50. Because it was already 11, they're raising it by $4.50. And they'll make $4,805. It's going to be close. Last example. I've got the PDF of your marks. I'll print it out. Many of you are going to be very happy. Big upgrades in marks for some people.
Did I get a big upgrade in marks?
I'm not going to say out loud what people's individual marks were.
He's not
But I'll get it printed out for you. Oh, no, you just wrote it. No, I don't know. These are the people, I'm updating their marks to people that wrote yesterday.
Can you give me an A plus on that test?
What's that?
Can you give me an A plus?
I don't know. Until I'll mark it.
$5 for an A plus.
You think a teacher sells out for $5?
didn't say anything.
Maybe.
$5 doesn't get me off the couch, buddy. I won't even sit up straight for $5. Student council will, though. $4.50. The path of a soccer ball that's kicked in the air can be modeled by this function. Oh, you're going to be happy with these ones. They gave the equation. Whew. No tables, no let statements, just math. It's good. What is the maximum height of the ball? Okay, so maximum height, what does that trigger? Underline that. Vertex. And if I want the vertex, what procedure am I going to have to go through? Complete the square. Okay? So that's important thinking in all this. Don't underestimate writing that down. You're like, oh, I'll remember that. I'm like, we got to talk about zeros coming up. We'll get confused. Like last chapter, we'll get confused which way to go. Right? So when you see maximum, you're thinking vertex, you're thinking complete the square. Hi. I don't know. Let's check the big can.
That's okay.
We struck out. Not a lot of pop drinking in this class. Now, if they started collecting Starbucks caps, I think we'd do pretty well probably, would we? Do I have your full attention? Are you now like, obviously I'm going to have to learn to complete the square. It's a tough procedure, but it's very repetitive. Here's the steps every single time. Common factor off the A coefficient. Don't common factor it off the 1. And if you're having trouble with it, I think my video that I made the other day is a good one to rewatch on the individual pieces of this. But this will get repetitive. Common factor that off. Then a little thought for the magic number. This time it's -4 divided by 2 squared. See, same every time. This thinking's the same every time. What's the magic number? Take the new b, divide it by 2, and square it. Add that 4 and subtract that 4. Now, if you've chose the right number, that little trinomial there will factor as a square.
Is that a plus or a minus 1?
Plus 1, thank you. Plus 1 over there, good. What two numbers multiply to +4 but add to -4? It's -2 and -2, but look, it's always going to be there. So when you get into fractions and you get to the ridiculous ones, you're like, how am I supposed to know? It's always that number in there that it actually factors as. So h equals -5, t minus 2 squared. And then I'll finish it off, and then I'll pause because I need someone to tell me, where did the 20 come from? Yeah, it's the most common error by far. And I think I promised I'd give a mark just by showing that error, or that arrow. Not error, that arrow. I get a mark for just drawing that arrow? Yeah, because it's easy to forget. That's the most common error. If I can get you to do that, a whole bunch of people won't make that mistake. Now, I say once you get it completed like that, once you've completed the square, then draw a little tiny diagram of what the heck is going on here. And what we found out is that at time 2, this thing has a height of 21. Now I'm opening it downwards. Anyone tell me why it's opening downwards here? What is it about this question that tells me it's opening?
Maximums up at the top.
Yeah, and with the negative out there, it's opening downwards. Don't try and answer the questions until you've drawn that little diagram. It doesn't have to be that great. Just enough to go, okay, what are we talking about here? And then I can answer the question. Maximum height, max height, 21 meters. I can see it right out there. How many seconds till it reaches this maximum height? 2 seconds. I can see that right on my little diagram. It's 2 seconds to get to 21 meters. C, how far from the ground is the ball when it's kicked? What? How am I supposed to know that?
The plus one.
The +1, yes. Find h when t equals 0. So h equals -5, 0 squared, plus 20 times 0, plus 1. I get the feeling he didn't do all that math. He just looked and went, I know what's going on here. If all those are 0, the initial height had to be 1. So whatever the soccer ball was, it was kicked from a height of 1 meter. Those are hard. Those are hard. Do you have questions about this one, though?